Welcome to the presentation on Streamlit. In the next few minutes, we will dive into what Streamlit is, how it works behind the scenes, and why it's becoming a go to tool for developers and data scientists to create interactive web apps all in pure Python. Streamlit allows you to build and deploy dashboards, machine learning models, data science projects, AI powered applications, and many others quickly with minimal effort. You don't need to know HTML, JavaScript, or CSS, just Python. Now let's see how it works and why it's so efficient for data driven apps. I will explain how Streamlit handles user interactions and code changes and how the app updates dynamically. When the user interacts with the app, such as clicking a button, adjusting a slider, or entering data, or if the source code of the app is modified, Streamlit detects this as well. Streamlit detects the changes through a user interaction or change in the source code. It rerun the entire script from top to bottom every time the app detects an update. The results are reflected in the browser instantly. This might seem inefficient because Streamlit rerun the entire script whenever there is a change in the source code or user input. With caching, Streamlit stores data or resource intensive operations so they don't rerun unless necessary. Streamlit automatically reruns app whenever there is a change, but with caching, it becomes much faster by reusing existing data and skipping repetitive expensive calculations. This is a powerful feature for building real-time applications without sacrificing performance. We will see the demonstration of code and working in this video. In Streamlit, caching optimizes app performance by preventing redundant operations. st.cache data and st.cache resource handle data and resource caching, ensuring efficient use of external data and function. On left hand side, st.cache data caches data that can be stored in a database like Python primitive strings, integer list, data frames, and API calls. This prevents unnecessary recalculations or repetitive requests, improving app performance by retrieving cached result only when needed, significantly speeding up the app. On the right hand side, st.cache underscore resource is for caching item that can be stored in a database like machine learning models and database connections, preventing repeated loading and initializing, thereby improving app performance and efficiency. Streamlit key features include multi-page apps for organizing complex workflows, caching to reduce redundant operations, easy to add interactive elements like sliders, text, input, button done with just a few lines of code, and real-time updates making it ideal for fast prototyping and efficient data handling. In the upcoming sections, we will dive into practical examples of how these features work, including session management, caching, and deployment options. To set up Streamlit in Visual Studio, Python version supported for Streamlit is 3.8 to 3.12. We will create the environment using conda, install Streamlit, and test the installation by running the command streamlit hello. I am creating the conda environment with Python 3.10. Activate the environment after that. Install the Streamlit using the pip command. Run Streamlit hello to verify the setup. It is opened and and I am seeing the web page. Now that we have completed the installation, let's build the first simple application and test how Streamlit automatically reruns and applies changes whenever we modify the code. I am demonstrating the rerun function in Streamlit. First, I created a Python file and added Streamlit library. Then I added simple text to display on the browser and ran the code using Streamlit run first app.py command. Now let's make a change to the code and see how it prompts for a rerun. Once we rerun, the changes are applied to the browser. I made the change again and it is applied to the browser. Each time the code changes, it will rerun and apply those changes. We start up from first application by setting up the page, creating the form and handling form submission to capture user inputs. After that, additional information is displayed based on the submission, followed by a footer to complete the app layout. For setting up page, I set the title as simple web form with Streamlit title. Run the Streamlit app and it will display the result. Added a header now to the page titled user information for setting up the page option. After save, now the code changed option have appeared. We will select always rerun to apply the changes. I'm adding a text input field labeled input. Enter your name to create the form. A submit button triggers the code inside the if block when clicked. After click save. After entering the name and submitting the form, the name is displayed on the page using the STWrite. Now I am going to write the code for a drop down to allow selecting option. I will add st.write for the option to print when the submit button is pressed on the web page. Now it will select the box, either of the options will come and need to choose that. Once this is done, we will click on save and the code automatically reruns. Now I will select the option and submit. The output is displayed on the browser. A slider is now adding with the range from 1 to 100 with the default value of 50. The slider is include also inside the button block to display the value of it. Now when we click on the submit after selecting the values on slider, the name drop down option and selected slider values are displayed on the web page, displaying additional information like a header, displays message explaining like uh, fill out the form above and Click the submit button to see detail. So now I will save and submit. The It will show me the output. Yes, it's showing me the output. Now I'm going to add the footer with a brief message created with Streamlit, a simple web app framework for Python. Click save and submit button. The result is displayed on the browser. We have set this up in our first Streamlit code using Python. You can see that only a few lines of code were needed to achieve this. I am updating the same code with additional options such as radio buttons, checkboxes, a date picker for selecting a birth date, further customization of appearance, data processing, and calculations, integrating with other Python library Panda. First, add a radio button for selecting the gender. Include it inside the submit button block. Save it and the code will rerun like before. Press the submit button and it will display the result. Next, add checkboxes for selecting hobbies, reading, traveling, and cooking. We use for the checkbox options. For traveling, add it. Okay, another if statement for the checkbox for cooking, and include them inside the button block. The join code conditionally displays the selected hobbies or none if no hobbies are selected. Click save and code reruns. Now if you click on selecting the option of reading, traveling and submit, output displayed with reading and traveling. Next, we are adding a date picker field to allow the user to select a birth date. The default date is displayed in the date picker. Yes, it will take it as an input. On the browser, we will set the date time for a birth date. Click save and code will rerun. Yes, here we are calling. So now I'm selecting the date and it's January 1998 year and the day is 9th and month is January, and when I click on the submit button it will display the result. Now further customize by adding a subheader for the name, and checkboxes for the hobbies. To look more interactive on the browser, save the code and press the submit button. It will display the output along with the subheader that we have added for checkboxes and hobbies option. Now add the data processing to calculate age by subtracting the current year from the birth year logic. And secondly, the boolean checks in this command checks if today's date is earlier than the birth date's month and day, and return the value 1 or 0 based on that, and subtract that value from the previous result to give the correct output of the user age. Click save, return age. Now before saving, let's write the function call for age function. Yes. Also add the subheader for the submitted information which was missing before. Save. Now add the submit block for this age here, and save and press submit. It displays the age. Yeah, it's showing 26 here. Now let's integrate with other Python libraries for data analysis. We will use pandas for this purpose. We will display the result of this submit block in the data frame of panda. Let's select the options as a table field. Now put the values of these fields. I am using a magic command here. What this do is, instead of writing the Streamlit function, I'm going to use only the df, and it automatically detect that as a data frame output for Streamlit and displays the output. Now click save, and Streamlit automatically detects and displays the output after clicking the submit option. And error is showing. Let me change the code values from string to sorry, from integer to string. And then click save and submit. Now no error and everything looks fine. We explored all these options in our code completed the setup of the first app, and saw how each feature works with simple code. In the second application, we will demonstrate user authentication, cache, session states, user roles, and multi-page functionality with a fully functional dashboard. I will explain the code and its working, then explore the cache functionality, authentication session states for login and logout, and the roles for admin and user web pages within the code. This is the code I have. Let me explain all the details and then we will run the app and test it by adding more lines to demonstrate the working of Streamlit components like data and resources, caching, user roles, admin and normal user, and session state values. I will explain the code first, then proceed to show how it works. We start by initializing the session state. Streamlit st.session underscore state allows us to store values across different interactions. Here we initialize two values: logged in to track whether a user is logged in, and role, which can either be admin or user. We define an expensive computation on function to simulate heavy operations using st.cache data, cache results, improving performance. I will demonstrate this with a practical test. We implement an authentication system where the authenticate function checks user credential, returning their role, admin or user, or none if the credentials are incorrect. This calculate age function takes the user's birth date and calculate their age based on the current date. We will use this function later in the user profile section of the app to display the user's age. We simulate a database connection using SQLite and the st.cache resource. Decorator caches the connection to avoid reconnecting each time the app runs. It is creating a user table and displaying records. I will demonstrate this later. The home page lets users select a number with a slider. The expensive computation function runs once, speeding up subsequent runs. I will demonstrate this by adding more code and displaying results. The user profile page lets user enter their name and birth date. After submission, the calculate age function determines their age and a personalized message is displayed. The admin dashboard page displays user information from our simulated database. The cached database connection ensures that the data is retrieved quickly. The data is shown in a table format using st.data frame. The logout function resets the session state variables, logging the user out. After resetting the session, the page is refreshed using refresh page, which clears the user view and redirects them. We implement the main app logic, displaying the login page or navigation option based on session state. Admin access extra features, logout clears the session, and reset the app. Page rendering dynamically change based on user's role, allowing admin to access the admin dashboard and regular users to view their profile. We will explore the power of caching in Streamlit using both st.cache data and st.cache resource. First, we use st.cache data to cache the result of a heavy computation. Let me show the code and the modification done for testing. Here, we intentionally simulate a delay of few seconds to show the impact of data caching. We use st.cache resource to cache the database connection, preventing delays. We simulate a delay of 5 seconds here. On the home page, this handles heavy computation using data caching. After the first run, the data is cached. We simulate the clearing the cache using the button and rerun. On the admin dashboard, the connection is cached to prevent repeated delays from re-establishing it. We will compare the time taken with and without caching. We will simulate clearing the cache using the button and observe the result. I have not saved this code with the changes done as I shown you. First, we will simulate the dynamic page rendering between users to access different pages based on their role. Run the app. Page is loading. I will log in first as a admin user. After login, admin can access the home page and dashboard. On home page, it multiplies the user selected number by 2, currently running without simulation. On the admin dashboard, the connection is currently not cached, so you can see the delay in connecting to the database. Now I will log out and log in with the regular user. Regular user can only access the home page and their profile. The navigation changes dynamically based on user roles. As you can see in the profile, I will add my name and birth date, and after click on submit, it will display the name and age. Now for cache simulation, I am going to save the code and rerun it. After logging using the credential of the admin, we first observe the data cache. If you notice, there is a delay. Here I pick the number 2 now, and it takes 5 seconds to display the output. Next, I switch to the admin dashboard, pick the number again, and this time it shows without delay. Let me clear the cache again, and now it again takes 5 seconds to display. For the resource cache, the database connection output is cached. Now let me clear the cache and go back again. It takes 5 seconds to display the output. Now let's check for the session state for admin and user role. We are testing session state management in Streamlit, especially focusing on how the session state changes for admin and normal user. Let me now run the app and we will see this how it works. I am logging in with the admin user. The session state is updated to track whether they are logged in and what the role is, either admin or user. The session state is displayed in the sidebar, allowing us to observe these changes in real time. If the user is in admin, they gain access to both the home and admin dashboard pages, and we can see current session state in the sidebar. Now, user on the other hand can access the home page and their personal profile. Current session state in the sidebar is logged in true and role as a user. We can also see how session state is cleared when the user logged out, resetting the session and role. This shows how the Streamlit session state for controlling user access and handling state management efficiency across different parts of the app. This completes the second app. We check the user authentication, role-based access, admin user, caching of data, st.cache data, and resources, st.cache resource, session state management, multi-page navigation with page rendering, and the dashboard displaying user data and computations efficiently. This application demonstrates user authentication based on roles and secrets, real-time dashboard, advanced caching, and visualizing data from Google Sheets. Let's walk through each features to understand how it works and how the code is structured. This sets up a wide layout perfect for data-heavy pages like dashboards. This functions load user data like usernames, passwords, and roles from secrets.toml file, allowing us to securely manage login credentials. MD5 is used to create a hash of the password. This hash is what gets compared to the stored hash in the secret file. We check the credentials and if correct, set session variables such as logged in, username, and role for the user. Here, set up role based navigation. Admin can access extra pages while regular users have limited access. We simulate live stock price update using pandas to generate stock price data and plotty to display the chart. User can control the refresh rate and start stop updates on the fly. All of this is managed using session state variables. We fetch and display data from a public Google Sheet. Instead of using an API, we convert the Google Sheet URL into a CSV format and load the data using pandas and also using data cache. We're using TTL value of 600 seconds. Once we have the data from Google Sheet, we can visualize it using Plotty, the main app flow user session to check if the user is logged in. If so, it renders the appropriate navigation and pages. Let's start with demonstrating work how it's functioned. I will run the third Streamlit app. It will open inside the browser. I will log in with the admin user and based on the role navigation option in the sidebar available is admin page, user page, real-time dashboards, and Google Sheets data. I will select each of the options. In the real-time dashboard, user can set the refresh interval using a slider ranging from 1 to 10 seconds. We set it at 5 seconds by clicking the Start Real Update button. The update begins and stock prices refresh after every 5 seconds as we are seeing it. The app retrieves data from a Google Sheet and displays it as a scatter plot. To enhance performance, it uses Streamlit caching with st.cache data, storing the data for 600 seconds. This prevents reloading the data every time, speeding up subsequent page visit. If the cache expires or data changes, it reloads automatically. Data cache is working here. Now I will log out and log in with the user 2. Regular user can access the user page, real-time dashboard, and Google Sheets data. I will simulate the same real-time dashboard with the normal user. The time is changing after 5 seconds. As you can see, now it will change. Yeah. On Google Sheet, page data cache did not take time to load. As we can see now, this is the secret file which contains hash passwords of users and their roles. It also includes the Google Sheets URL that I am using in the demonstration that I shown you before. That completes our third Streamlit application. In this, we have seen user authentication and session management, secured user login system using hash passwords, role-based navigation for admin and user roles, Google Sheets integration, simple efficient method to fetch Google Sheet data as a CSV and load it into a Panda data frame, displays the data in a table and visualize it with the line chart with plotty real-time dashboards. That's it. We have completed the overview of Streamlit, starting with the basics and moving into advanced functionality. I will cover deployment in a separate video. In upcoming videos, I will show you how to use Streamlit for machine learning, data science, and other projects. If you found this video helpful, don't forget to like, subscribe, share, and leave a comment with any question. Thanks for watching and stay tuned.